Anyone who's been to the Midwest knows that locusts are a serious problem. They eat massive amounts of crops and reproduce at an alarming rate. But I always wondered what the evolutionary advantage is of the locusts. Why create so many offspring only to run out of food and die in a short amount of time? The answer came to me much later, and I found out surprisingly that the common locust is not much different from that of a tomato. Types of species growth. Remember, the maximum amount of species an ecosystem can sustain is called the carrying capacity. Remember, the carrying capacity is how many organisms can fit into an environment. Too many can lead to overcrowding and a loss of resources. But because there are different rates of reproduction, this must mean that organisms reproduce at a different way. Today we're going to be looking at the types of species that organisms are in terms of growth rates. Some grow more than others and faster and thus reproduce faster. Others take a long time having few offspring. Let's look at the differences between the two. There are different ways species get to and treat the carrying capacity. The first involves our friend the locusts. Ways species populations grow. Our species. Our species have rapid population growth and crashes. Exponential growth. Our species are like flies, in which they're going to live for a short amount of time. Because of that, they're going to reproduce as many offspring as possible to try and ensure that even though many will die, some are going to live. Breed quickly with lots of young and don't live long. Here's a sample graph. On the y-axis, you'll see population, and on the x-axis, time, with the dotted line being the carrying capacity. The graph shows that the species population will climb rapidly, then crash, and then climb rapidly again. Examples of our species are rats, insects, grasses, and bacteria. All of these organisms are characterized by having very short lifespans, so they reproduce as quickly as possible. They may cross the carrying capacity, but they will always bounce back. Our friends the grasshoppers are like this, as well as rats, bacteria, and of course, the tomato. I don't think it'll ever get this extreme, though. Let's take a look at the opposite of this. If our species are great at growing really, really fast, let's take at the ones that grow really slowly, the K species. K species. K species have slow growth and rarely pass the carrying capacity. These are examples of species like elephants, who due to their size as well as the amount they eat, reproduce slowly, once every few years, and usually only giving one offspring. They're fine though, as they live for an awfully long time. This is called logarithmic growth. K species live a very long time, and thus have no need to breed as quickly. We call this growth logarithmic growth, as it typically follows a slow, steady slope, ensuring slow growth. Breed slowly with few offspring, but live a long time. Here's a sample graph. This time, we see that they have a slower growth, and instead of crossing the carrying capacity, merely hover just below it. This probably means that there are an equal amount of deaths as births. Examples of K species are trees, whales, lions, apes, and sharks. Once again, remember, trees, gorillas, whales all live a long time and reproduce few with logarithmic growth. How to remember to keep them separate. One way is the R in our species is for rats. Another is for R growth, think of ER, exponential R species. Lastly, trees are K species. Logs come from trees, logarithmic growth. Your goal tonight is to be able to tell me if humans are R species or K species, and use a reason to justify your answer. Have a good one.